For today's agenda, first, the definition of logarithmic function. Second, rewrite exponential function to logarithmic function and vice versa. Third is to solve logarithm. Logarithmic functions are the inverses of exponential functions. The logarithmic function y is equal to logarithmic of x base b is defined to be equivalent to the exponential equation x is equal to b raised to y. Express logarithmic equation exponentially. So before you begin, learn to express a logarithmic equation exponentially. We have 5 steps to follow. The first one is to know the logarithm definition. Before you can solve logarithms, you need to understand that a logarithm is essentially another way to write an exponential equation. Second, look at the equation. When looking at the problem equation, identify the base, b, exponent, y, and exponential expression, x. Third step, move the exponential expression to one side of the equation. Set the value of your exponential expression, x, to one side of the equal sign. Then fourth step, apply the exponent to the base. The value of your base, or b, needs to be multiplied by itself by the amount of times indicated by your exponent y. And the last step is rewrite your final answer. You should be able to rewrite the logarithm as an exponential expression now. Verify that your answer is correct but by making sure that the both sides of the equations are equal. So let's try it to solve step by step. First, know the logarithm definition. So we all know that y is equal to logarithm of x base b if and only if b raised to y is equal to x. Note that your b is the base of the logarithm. It must be true that your b is greater than 0 and b does not equal to 1. In the same equation, y is the exponent and x is the exponential expression that the logarithm is set to equal to. Second, look at the equation. So let's have an example. 5 is equal to logarithm of 1024 base 4. Let's identify the value of the base, which is the b, the exponent, which is the y, and the exponential expression, which is the x. Again, let's have the base. Base is equal to 4. So this will be your base. And then, let's find out the value of y. Y is equal to 5. So this will be your y. And then lastly, let's have the value of exponential expression, which is x. Okay, that is 1024 and this is 1024. Let's move on to the third step. Move the exponential expression to one side of the equation. So again, we have b raised to y is equal to x. So our x value that we get in the last example that we have is 1024. And let's rewrite it into one side of the equation. So that will be 1024 is equal to the unknown. And then let's move on with the fourth step. Apply the exponent to the base. So we have b as 4 and y as 5. 4 is our base and y is our exponent, meaning to say we will multiply the base 5 times to itself. So that will be 4 times 4 times 4 times 4 times 4. Or we can rewrite this one as 4 raised to 5. Lastly, let's rewrite our final answer. So from 5 is equal to logarithmic of 1024 base 4, we can rewrite this one exponentially as 4 raised to 5, which is equal to 1024. If we will do the checking, we will multiply 4 5 times to itself. 4 times 4 times 4 times 4 times 4, and that is also equal to 1024. Let's have more examples. Example number 1, we have logarithm of 8 base 2 is equal to 3. So we have the base as 2, or b is equal to 2, y is equal to 3, and x is equal to 8. So we get x as 8, then we'll put it into one side of the equation. And then we have 2 raised to 3, or 2 multiplied 3 times to itself. So that will be 2 raised to 3. And then, finally, we have 2 raised to 3 is equal to 8. If we will recheck if our answer is correct, let's try to solve this one. 2 times 2, that is 4, and times 2 is 8. And 8 is equal to 8. Second example, logarithm of 625 base 5 is equal to 4. Our b is 5, y is 4, and x is equal to 625. Let's put 625 on the one side of the equation. And then, let's have our base, which is 5, multiplied to y, which is the exponent, or times the exponent. So that will be, you will multiply 5 4 times to itself. 5 times 5 times 5 times 5, or you can rewrite this one as 5 raised to 4. To simplify that, we're having 5 raised to 4 is equal to 625. To recheck that one, let's solve 5 raised to 4. 5 times 5 is 25, times 5 is 125, times 5 is equal to 625, and 625 is also equal to 625. Let's move on with the third example. Logarithm of 243 base 3 is equal to 5. So we have the base, which is equal to 3, y, which is equal to 5, and x, which is equal to 243. Let's move x on the one side of the equation, so that will be 243, which is equal to the unknown. And then we have the base raised to y, so that will be 3 multiplied 5 times to itself, or simply 3 raised to 5. That means we have 3 raised to 5 is equal to 243. To recheck that one, let's solve. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is equal to 243. That means 243 is equal to 243. For the fourth example, we have 5 raised to 3 is equal to 125. This time, we'll make it a logarithm. We have the base 5, y is equal to 3, and then x is equal to 125. Remember, we have b raised to y, which is equal to x, as our y is equal to logarithm of x base b. To simplify that, let's find out our y, which is 3, and then substitute x. So we have logarithm of x, which is 125, base b, which is 5. So that will be 3 is equal to logarithm of 125 base 5. And for the last example, we have 24 raised to 0 is equal to 1. Remember, in exponent, any number or variable raised to 0, that is always equal to 1. Let's find out the value of b, y, and x. Our b value is 24, y is 0, and then x is equal to 1. Again, we have b raised to y is equal to x. Y is equal to logarithm of x base b. The value of y is 0, so that will be 0, is equal to logarithm of x, which is 1, base b, which is 24. So that will be logarithm of 1 base 24. So this will be our final answer. Let's now move on in solving logarithm. In solving logarithm, we have 4 steps to follow. First, let's isolate the logarithm. Use inverse operations to move any part of the equation that is not part of the logarithm to the opposite side of the equation. Second, rewrite the equation in the exponential form. Using what you know about the relationship between logarithm and exponential expressions, break the logarithm apart and rewrite the equation in a simpler, solvable exponential form. Third, let's solve for the value of x. With the problem simplified into a basic exponential equation, you should be able to solve it as you would solve any exponential equation. And then lastly, let's write your final answer. The answer you got when solving for x is the solution to the original logarithm. Let's try it step by step. For the first example, we have logarithm of x plus 5 base 3 plus 6 is equal to 10. In this example, we need to isolate the logarithm. So we need to disregard or to isolate positive 6 on the left side. To, to isolate positive 6 on the left side, we need to add negative 6 on both sides of the equation. So logarithm of x plus 5 base 3 plus 6 minus 6 is equal to 10 minus 6. And we all know that 6 minus 6 is equal to 0. Then 10 minus 6 is equal to 4. So we'll be having logarithm of x plus 5 base 3 is equal to 4. We can now move on with the second step. Rewrite the equation in exponential form. So from logarithm of x plus 5 base 3 is equal to 4, comparing this equation to the definition y is equal to logarithm of x base b, you can conclude that your y is equal to 4, so this will be your y, your b is equal to 3, and then your x is equal to x plus 5. And then we can rewrite the equation by b raised to y is equal to x, and that will be by substituting 3 raised to 4 is equal to x plus 5. And for the third step, since we already rewrite that one in exponential equation, we can now solve for x. 3 raised to 4 is equal to x plus 5. We all know that 3 raised to 4 is equal to 3 times 3 times 3 times 3, which is equal to x plus 5. Solving that, 3 times 3 is 9, times 3 is 27, times 3 is 81. So we'll get 81 is equal to x plus 5. To get the value of x in this equation, let's add negative 5 on both sides. So 81 minus 5 is equal to x plus 5 minus 5. 81 minus 5 is 76. 5 minus 5 is equal to 0. So we'll get 76 is equal to x. And then for the fourth step, let's write our final answer. So that will be x is equal to 76. Let's try more examples. Logarithm of x plus 2 base 5 is equal to 3. In this case, let's find out the value of y, b, and x since we don't need to isolate something in the left side of the equation. Y is equal to 3, b is equal to 5, and x is equal to x plus 2. So, let's substitute it using b raised to y is equal to x. We'll get 5 raised to 3 is equal to x plus 2. And then let's solve 5 raised to 3, which is equal to 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. So we'll get 125 is equal to x plus 2. And then, for this one, we need to add negative 2 on both sides of the equation. That will be 125 minus 2 is equal to x plus 2 minus 2. 125 minus 2 is equal to 123. And 2 minus 2 is equal to 0. So we'll get x is equal to 123. Let's move on with the second example. Logarithm of x minus 4 base 2 plus 5 is equal to 8. This time, let's isolate positive 5 by adding negative 5 on both sides. We'll get logarithm of x minus 4 base 2 plus 5 minus 5, and that is 0, is equal to 8 minus 3. 8 minus 5 is equal to 3. So we'll get logarithm of x minus 4 base 2 is equal to 3. Now, we need to find the value of y, b, and x. Our y here is 3, b is 2, and x is equal to x minus 4. Let's substitute it using b raised to y is equal to x. And we'll get 2 raised to 3, which is equal to x minus 4. Simplifying that, 2 raised to 3 will get 2 times 2 times 2, which is equal to 8. So 8 is equal to x minus 4. Then, let's add positive 4 on both sides of the equation. 8 plus 4, that is 12. Negative 4 plus 4, that is 0. So we'll get x is equal to positive 12. Third example, we'll get logarithm of x minus 6 base 8 is equal to 4. Since wala tayong dapat alisin, so we'll move on in finding the value of y, b, and x. Y is 4, b is 8, and x is equal to x minus 6. Let's substitute it using b raised to y is equal to x. We'll get 8 raised to 4 is equal to x minus 6. 8 raised to 4 is equal to 8 times 8 times 8 times 8, which is equal to x minus 6. By simplifying that, we'll get 4,096, which is equal to x minus 6. Then, let's add positive 6 on both sides. So, we will get x is equal to 4,102. Number 4, logarithm of x plus 12 base 2 minus 3 is equal to 3. Let's add 3 on both sides. We'll get logarithm of x plus 12 base 2 is equal to 6. Y is equal to 6, b is equal to 2, and x is equal to x plus 12. Let's substitute it. We'll get 2 raised to 6 is equal to x plus 12. 2 raised to 6 means 2 times 2 times 2 times 2 times 2 times 2, and that is 64. 64 is equal to x plus 12. Then we'll add negative 12 on both sides of the equation. So 64 minus 12 is 52. 12 minus 12 is 0, so we'll get x is equal to 52. And for the last example, logarithm of x minus 5 base 7 is equal to 3. Y is equal to 3, b is equal to y, and then x is equal to x minus 5. Let's substitute it. We'll get 7 raised to 3 is equal to x minus 5. 7 raised to 3 is equal to 343. Then let's add positive 5 on both sides. So that will be x is equal to 348. Thank you for listening. God bless everyone.